Hey everyone, welcome to a new video of my GameAudio Tech Tip series. Today we're going to talk about line traces, and I'll be using a Foley Footstep example to demonstrate what I'm going to show. And today we are also joined by Theo as well. But anyway, yeah, line traces are a bit of a strange one on the topic of game development. Line traces are not bad. People say they hate them and they're bad, but they're not. They're not an issue. It's more what you do with them that can scare people. But either way, what we're going to look at is how we can take the concept of a line trace and taking away the unnecessary elements of it that we don't need to do. And that all makes sense in the video. Basically, we're going to look for a solution to not do a line trace every frame. Before we get into that though, I do want to mention a couple of things. So it's been a while since I've done one of these videos, and there's a few reasons for that. One reason is last year I was going through some personal matters, and it affected my mental health and my confidence, and I kind of shut myself off from people in the world. But I am feeling much better now, so we're in a place that I can kind of have the headspace to do this thing again. That's good. Another reason is I've not had comments on this, but I've got the impression that some people, at least professionals, would look at the videos and wonder why I'm showing things in the way that I do sometimes. Whereas obviously people that are studying or newer to this kind of work really appreciate these videos, and that is mainly what they're intended for. It's for a newer audience. So yeah, the impression I got from people was, I just want to be clear on that, is like when I started off this channel, my aim is basically to shed light on the topic of technical sound design. Well, that's what I do, that's my job. And you know, when I first started out, I was pretty much self-taught. It was all like taught, everything I did was self-taught, and obviously I work professionally for a large company, so obviously, and I do this every day, so obviously my knowledge grows and grows every day. But yeah, when I first started out, there's not a lot of resources out there. So that's what I'm trying to give back to the community, and you know, help out people in this regard. But you know, it's important that people understand that, you know, at the end of my videos as well, I'll say I encourage you to take this and evolve it, find ways to make it better. And what I mean by that is, I'm not intentionally setting people up to fail, but I kind of don't want people to just me teach them, like give them things in full. I want people to kind of have a first pass or like an intro into that topic, and then find ways to actually make it better and improve it, put their own spin on it, and then use that as a learning resource of what is good about that, what is bad about that. That's really the intention of these videos. An example of, I think it was the reverb video, where the first function took in 8 vectors, for example. Like, that's stupid, you shouldn't do that. And that isn't to catch people out, it's purely so that someone would look at that and think, actually, why don't I just bring in an actor reference, and then that would then split out into the vectors. So it is really about, you know, people going through that journey of, here's an idea, how do I elevate that? How do I make it better? Another thing as well is, I work for a large company, so I can't use that company. I have to be careful about the stuff that I cover as well, so it can be seen as an endorsement. So I'm basically just protecting myself. So I will never introduce myself and say where I work, and then, because that can be seen as an endorsement for these videos. So again, like when I do things, it can't necessarily match too closely to what I do at work. I'm just basically protecting myself. So those are the kind of key factors that people, you know, I do want to make clear and people should understand. So yeah, I did want to touch on that a little bit. But yeah, let's get started then. So yeah, usually I don't really work with audio in these videos. I tend to just use debugging. So like the splines, for example, you know, we'll cover the topic of splines, and I'll use like a debug draw to say where the emitter would be, and I don't actually do anything with audio. So today I will actually do a little bit of that, and we're going to use Ys as well. We're not going to go into Ys, but I will be using AK components, and we're going to play some footstep sounds basically. Yeah, let's get started then. So yeah, here we are then inside Unreal. This is just literally the standard third-person project. So when I click play, it's just, you know, we have Manny, the mannequin. So yeah, let's start making a blueprint class then. This will be an actor component. Yeah, so I mentioned before then that this is, we're going to make like a very simple footstep detection solution, as people would with line tracers, and then we're going to take those line tracers and do something else instead to provide the same result. So this is like an optimization basically. Yeah, cool. It'd be an interesting topic to talk about. So yeah, let's look then. So really, Manny. So where is Manny? If you're not sure, you can just press play, F8 to click him, and then edit your character. If you don't know where to look in the project, that's a quick way you can find them. So I already have 2 AK components on him already from when I did this as a little practice. I like to do that before I do the videos. So yeah, this, you would just literally make some AK components and call them something like AK foot right, AK foot left. That's all I've done as a step before this. This is made on the character. We could in theory do everything else on the character as well, but I'm just going to do it on a blueprint component. Just so we're a bit away from the character in that regard. So since we're not on the character at the minute, we need to get the references to his emitters, and we need to do something. So what we're going to do is we're going to get owner, because we're a component, and we're going to cast to third person character, because we're going to attach, our owner is going to be a third person character. And these AK components are variables on the third person character. So we need to be able to get them. So on here, we're just going to say, we're going to cast the character, and as that, we're going to get the list of these variables that exist on it. Okay, so we're going to get these foot variables. And what we're going to do is we're going to make them variables on our component level. So these are positioned, if I go to the viewport on the character, they're positioned about where the feet would be. This isn't super important right now because we'll see in a second why. So what we want to do is on tick, what we want to do, in fact, I need to, yeah, so on tick, we want to draw debug sphere, okay? And at the location of AK foot left, we want to get the location. Basically, we just want to make sure that from right now is are they positioned where we expect them to be, relation to the character. That would help if I added this, wouldn't it? Foot. So we need to add this actor component to the character. So let's make this like 20. So we can see when I don't move, it's positioned at the foot as it was on the character, but as the foot is moving, the sphere is just it's relative to the capsule, not the actual, it's not attached to the character. So that's what we're going to have to do next. So to attach, what we need to do is we need to say attach component to component. And the parent is going to be the owner, but we need the mesh. So from here, we want to say get mesh. Okay. And we're going to promote that to mesh as well. Or what we, yeah, let's just do that. Okay. And we need to attach this to a socket. So sockets are a thing that we're going to cover now. So if we open up Manny and then go to his skeletal mesh here, we can see that there's a bunch of sockets that we could use. So for example, foot right, there's a socket here called foot right, or a bone rather. Now we could use this, or we could use the ball of the foot or something like that. I wouldn't usually recommend doing that though, because if we associate our blueprint to this socket and someone else changes the name of that socket, or the socket gets taken away, our blueprint will break. So we essentially want to protect ourselves a little bit. And also it might not be at the position we want it, and we shouldn't move this obviously. So we're going to play it safe, and we're going to add a socket here. And we're going to call this one audio foot right. Okay. And we're going to position this somewhere that makes sense for us. Now I like to do usually roughly about here on the bottom of the foot. And what I tend to do as well is these values here, I'll round them up. So let's make that one 8 and then -8 and then just put that to 0. That's fine for now. And then we're going to do the same on the left foot as well. So we're going to add a socket. Audio foot left, and then what we'll do is filter here for audio sockets, and then on the audio foot left we're going to basically mirror these values. So we've got 8 and -8 here, so we're going to put -8 and 8 here, and that should basically just mirror our position now from the other foot. Okay, so now this is the kind of space that we're going to look at. So what we're going to do then is back on our blueprint, when we're going to attach, we're going to add our foot left to our audio foot left socket. Let's just copy paste that. And we're going to swap our references to this one, and we're also going to type now foot right. So now we're essentially attaching our AK components to the actual sockets on the skeleton. That's what this is going to do for us. So let's click play them. And we can see that this is not looking right. And the reason for that is because the snapping rules here are relative. So we want to snap them to the target. And then now we can see as our foot moves in the world, our emitters, you know, we're representing that emitter in world space much more clearly. And what I would also recommend as well is this component is ticking by default. So what we can do is just turn off start tick enabled, and then enable tick enable here after we attach. And then what you could also do is set up some validation to say, did both of these actually find the socket name and attach? And if they did, then we can tick. If they don't, then do some error. So yeah, that's like the first step now. So we've got everything working as a first pass for us now, which is good. So next thing then is we want to basically take this sphere draw debug into an actual trace. So we're going to do SphereTrace by, I cannot type tonight, SphereTrace by channel. And we're just going to do one foot for now, because it just saves repetition on my end. And we're just going to trace our spheres. And we're going to draw debug here as well, so we're still getting that representation. So you can see when this sphere underneath my left foot now, when it's green, it means we've got a hit. When it's red, it means we don't have a hit. So there's no collision. And this is kind of forming our like very basic footstep detection method. So what we can do from here is say branch, and let's do like a do once. And if we hit, we're going to do something once, and if we don't hit, we're going to reset that do once. And I'm going to take our component and we're going to post a sound event on this. Okay, and we're going to say fully footstep. So what we will expect then is every time we get a collision hit, we're going to play our sound, basically. So you can see it's kind of forming our footstep detection, which is cool. So yeah, like I say, this is our first pass of this method. And this, let's just say that this is feature complete. And you know, we want to profile this now to see the performance of it. So we're going to look at that next. Okay, so now we're ready to start our Unreal Insights job. But before we do that, we want to collapse this to a function so that when we're profiling our data, we're looking at one specific function and not the overall kind of actor graph. So let's collapse that to a function. And really, this should be a function anyway, to be honest. So we're going to call this footstep. And let's just see if this affects any behavior. So this is exactly the same logic as we had, but now it spams. And that's purely because this do once it doesn't have a concept of, let's just say, every time it's called, it doesn't know the state of it anymore outside of that event graph. Because it's collapsed now into a function. It's in a different space. So we need to basically replicate that behavior, and we need to do our own kind of solution for that. So let's promote that to a variable and just call this do once. Same thing. And we're going to branch from here. So whenever we get a collision here, we're going to then ask, do we want to do something once? So if we do, if we're false, we're going to set that to true and then play the sound. So if we have a collision here, true is have we played once? No. Then we're going to say yes, now we have, and then play it. And then whenever we get the no here, we need to make sure that we set that back to off, essentially. So we're basically just making our own little do once. So now we have the same behavior that we just had a moment ago. So let's look at insights then. So let's go to the third person map and we're gonna see if we can get this to work or not. Let's start our trace. Let's just start a session and we're gonna hit play. And we're just gonna walk around a little bit. Now let's stop our trace, and let's check our session, and let's type in footstep. Now we're not going to see it here. This is because we've not enabled stat events. So even though we have it enabled here, there's actually the console command we need to type in, which is stat named events. Stats named events 1 is this one. Once you do that, I think you actually have to restart Unreal as well. Yeah, so let's just restart Unreal and then we'll be back in on it. Okay, so now we've restarted the engine. And then we've, like, sometimes you have to look through these trace settings as well. Anyway, we're going to start a trace and we're just going to do like 10 footsteps and see what kind of data we get. Okay. Now let's have a look. So what we're going to do is click here, and I'm going to scroll through, like, let's say maybe like 8 seconds or something. I'm going to filter here for footstep. This is our function. So in here we can see our post AK event. We count 10 of these. So, but whilst we only did 10 events, the SphereTrace did 881 casts, basically. That's 16.2 milliseconds. So let's say hypothetically, you know, you kind of want to have this in your game, and someone says, oh, we can't have that, it's too expensive, and we need to find, you know, you're not allowed it, basically. And then you say, well, you know, we need it because, you know, this is the way that it works. And then they'll come back and say, no, we really can't have it. Is there anything that you can do? You know, these are the conversations that you're probably going to have at some point. So it's good to kind of have solutions to answer to that. So yeah, let's just remember that figure then, 16.2. Okay. So let's go back to our blueprint. So effectively, what I'm going to do is just going to play the game, and I'm going to type slow-mo in. Slow-mo 0.1. So this is time dilation in Unreal Engine. So we're going to move in slow motion. And if you think about the movement of this character, is effectively we want to detect when the foot hits the floor one time, and then effectively not do that again until the foot hits again. So a lot of people use line traces, and that's fine. You can still do that, but we're just trying to think: is there anything that we can do to increase performance? So effectively, if you think about what this motion is achieving, it's whenever the foot hits the floor. But how do you detect that? We need some kind of relationship between another thing, such as the character. So the foot belongs to the character. Is there anything that we can do on this character to assume that the foot has hit the floor? And there is. So what we're going to do is just think about angles and basically degrees. So whenever the foot is within a range of degrees, we can assume that we want to then do our trace. Okay. That's what we're going to do. We're going to try that. So we've watched this for some time now, and we're kind of getting some ideas in our head. And the idea we have is saying that really right now, in this frame here, in this frame here, this frame here, we don't need to be line tracing. So can we just reduce the amount of tracing that we do in this time? So when the character runs like this is called a gait, usually. G-A-I-T. This is kind of their motion. And the same would be for anything like a creature, a human, you know, a dog, an elephant, anything like that. They have a gait, it's called. And that's essentially what this is. It's like the range of motion of that cycle of footstep. So what we're going to do is, there's two ways you can do it. Is you can just get the range of the foot, and if you're in that range, we want to line trace, and if we're outside of it, we don't. And we could do that, but I'm just going to do something a little bit different. Is I'm just going to actually just get rid of the trace completely. And we're going to look at another method of triggering it without traces at all. So we have our foot left here. We're going to get the forward vector of our foot, because we know that the foot is facing this way. And if you assume the floor is flat, when the foot is in relation to the floor, we want to do something. Now, something else, we need another way to pinpoint this angle. And that is, what we're going to do to use that is we're going to get our mesh. In fact, we're going to go back to this, and instead of doing the mesh there, we're going to call this owner. Okay, so I've just basically, as my character, I'm getting the owner itself. So I'm going to bring that in, and I want to get a reference to my capsule. And the reason for this is because the capsule, if your character falls over or anything like that, this angle is going to change, but usually your capsule is pretty constant. So let's get the forward vector of our capsule. Okay. And we want to get the dot product of these values. And let's just for now print string and just see what we're going to get out of this. Let's just see what we're going to get. And we're going to name this string foot. I don't know, that's fine. And then we need to plug that in. So yeah, we've got some kind of number then at the top left there, but it's not really informing too much. But we do know at least that we can start to use two values to form a relationship between each other. And that's the important thing. Whenever this foot is facing forward, this basically becomes 0. That's the dot product of these values. These forward vectors, if we're facing the exact same way, are going to be 0. But we don't quite want to do that. We want to do something a little bit different. So we're going to get, it's not this one, degrees. So essentially, this is the inverse cosine, and it's hard to explain, but we're going to basically make a relationship between these two within degrees. So I'm going to get my print string again, and this time, yeah. So now, instead of that 0 number, we've kind of got 85. It should be 90, but there's kind of, if you look at the foot, there's almost like a slight offset of the foot, essentially. It's like off the floor a little bit. But effectively, we're getting a much nicer range to work with. So as the foot goes back, and again, as the foot is in this kind of shape and this shape to the floor, we don't care about it. We just don't want to. We don't want to know about it. We don't want to care about it when it's within a certain range. Now, what I would usually do in this case is get a range of 2 min and maxes and just focus on that. But what I'm going to do instead now is I'm just going to say if we're less than 95, then we're going to do something. So if you remember before, we had a SphereTrace here that was our condition of true and false. And we've just replaced the SphereTrace with this detection now. And if I walk, it's the exact same treatment as our SphereTrace, but we're not using a SphereTrace. So now let's do an Unreal Insight capture again. Okay, that's not quite right because there's one missing there, but we're going to change this anyway, but just as an example. Let's go here. And oh, this is way more stuff than before. Footstep. Footstep. So again, let's say about 8 seconds. We've got 5 of them there. We've got 9. So it's not quite 10. But if you look here now, we're at 10 milliseconds. So that's, if you go back to other image, we're at 16 before. So we've saved some time here. But something to bear in mind is we are doing other things now, such as printing string. We're doing other debugging as well, which doesn't help. Printing is expensive, actually. So we're going to turn that off because we still need to do another thing. So obviously, we still need to do a SphereTrace, right? Because the whole purpose of the footstep detection is probably to get the material as well. It's not just about detecting the foot hitting, but it's also about extracting the material from what we are hitting. So we still need to do that. Now, what I'm going to do is I would probably use a line trace normally for that, but I am going to use a SphereTrace in this manner because we used one before in our other calculation, right? So it would be unfair to do a sphere before and then a line after. So we're still going to capture our SphereTrace here. So now what this is going to do, if I just go to the debug drawer for one frame, is when we hit, you can see the debug drawer very, very sort of briefly there for one frame. So instead of, if I go back in slow-mo, if you remember before, we were line tracing constantly. Every update had that SphereTrace going off, but now we've replaced that with just bang, one instance of it. So now we already know it's going to be more performant. And this is the kind of way that we want to show that. So we've kind of basically found a solution. We've applied some logic to optimize it. Okay. So now let's do another insights capture then. So we're going to play. In fact, I need to turn the debugger off there because that's going to give us not the correct results. Let's play and we're going to capture our trace. 10 footsteps. Okay. Now let's open up our log here. Okay. Footstep. About 8 seconds, isn't it? Count for 10. So we've got 10 SphereTraces. And our overall frame for this then is 4 milliseconds. Frame, sorry. Our overall duration of this is 3.9 milliseconds to do 10 footsteps. Now let's just bring up our other one, just as a reminder. We posted 10 AK events and the whole footstep function cost 18.7 milliseconds. Instead, what we now have is our improved version where we're doing 10 post AK events. Our whole footstep function has now used 3.9 milliseconds to do. And if you look, SphereTrace single, we did 10 SphereTraces as opposed to 881. Because if you think about before, this 18.7 was our total function time. 16.2 milliseconds that was just tracing. So we've gone down the list of insights and determined that the SphereTrace is the most expensive thing. So we've basically just found a solution to optimize that. And we're achieving the exact same thing in the end result. So yeah, that will be it for then, because this has been a long one, especially with the intro that I did. So I'm going to leave it there. Hopefully people found that useful. And again, if you have any ideas of things you want me to cover, do let me know, because I'm starting to run out of ideas anyway. So it'll be good to kind of, do like a one for the community, I guess. If there's something that you want to know, maybe we can have a look together. So yeah, nice one. See you next time.